hope you are able to see. So yesterday this was the derivation with which we stopped. That is, we took v square minus u square is equal to 2as. Then we derived the expression for the relation between work done and kinetic energy, and I told you work done is equal to change in kinetic energy, and the name of this theorem is called as work energy theorem. And remember, it is very, very important. Okay, so with respect to CBSE, let me say how the question will be framed is, they will ask you to derive the work energy theorem for a constant force. So if they ask you to derive work energy theorem for constant force, these are the steps to be followed. Okay. The other way of asking the question is, they will ask you to derive the work energy theorem for a variable force. Then these are the steps to be followed. Okay. So work energy, write down the heading as work energy theorem for variable force. So starting with this, we know that kinetic energy is equal to half mv square. Accepted? So kinetic energy is half mv square. Then derivative of k with respect to t. Okay, see, I'm following the exact steps. Derivative of k with respect to t is going to be what? It is d by dt of half mv square. So whenever you're differentiating, I told you the constants can be taken out. Look at the expression. What are the constants that are there? 1 by 2. So m by 2 is a constant, d by dt of b square. So what is the derivative of b square? That is 2v into dv by dt. See, what I have done here is called as chain rule. Let me explain this. Listen to this carefully, or else you will have to memorize it. I've already explained this. What is the derivative of x power n?
Two x n minus 1.
It is
Nx n minus 1.
It is
Nx
n
n
into,
minus 1.
yes, n into x power n minus 1. Okay. Answer?
Nx n minus 1.
Right. But this is wrong. Because whenever you're differentiating, the most important parameter you need to concentrate upon is with respect to what? So if you look at the first scenario, you're differentiating with respect to x. In the second scenario, you're differentiating with respect to t. But what is the variable that is there? Variable is x. So when you have something like this, you need to first do the basic differentiation, that is n into x power n minus 1. You need to put a dot. Dot means into. You need to look for the variable for which you need to look at the variable for which you're differentiating. So what is the variable you're differentiating? X with respect to whom? With respect to time. Okay. So what you need to do is n into x power n minus 1 into dx divided by dt. This method is called as chain rule. Okay. This method is called as chain rule. Please make a note of it. The reason why I wrote it is, had the question been d by dv of v square, then my answer would have been 2v. But it is not d by dv of v square. Rather, it is d by dt of v square. So what should I do? I need to first write 2v into derivative of the variable with respect to dt. So that is why I wrote dv by dt. I hope you are able to understand this. You will learn about this only in your 12th standard, not even in your 11th. Okay, this is called as chain rule. Have it in your mind. Maximum there is one place where you apply it. So what will happen? 2 and 2 will get cancelled. So it is m into v into dv divided by dt is dk divided by dt. I hope you understood this part. Yes or no? So m into dv divided by dt into v. So if you directly read it from textbook, you will not understand. There is a reason.
You can explain
Okay.
a second part, sir.
Which second part?
Sir, that 1 by 2 m into d by dt v square, that one, sir.
I cancelled 2 and 2.
No, sir. Second one, sir. Above that. Above
This
that,
one.
sir. One, sir.
See, this is called as chain rule. If you are differentiating v with respect to v, then you will write it as 2v and leave. If you are differentiating v square, that is this v with respect to any other variable other than v, then you need to follow this chain rule. That is why I took the example here. When you took the first example, it is d by dx. When you took the second example, it is d by dt. When you do d by dt, you need to write dx by dt. Let me
Sir,
take another example.
not that
What
one,
is
sir.
derivative of sin x? Ah,
Sir, actually, first step you wrote dk by dt is equal to d by dt into half m d square, no, sir.
yes,
Then
half
second.
into m is a constant. It will come out of the derivative.
Oh, okay, okay, sir.
Ah. So m into dv by dt. But what is m into dv by dt? What is dv by dt in the first place? This derivation is important. Yes.
Acceleration.
So
Yes,
m into a into v. So what is m into a? It is force. Force into velocity into dk divided by dt. Is there any doubt till this step? I suggest you all to write it till this step. Finished?
yes, sir.
Okay. So listen. dk by dt is equal to f into v. So dk by dt we can write it as f into, what can I write velocity as? Velocity is ds divided by dt. Right? Now what we can do is this dt and dt will get cancelled because we know that velocity is equal to ds by dt. So what is left out? dk is equal to fds. Okay. Now what I'm doing is integrating on both sides. We get integral of dk is equal to integral of f into ds. So right hand side, look at the variable. The variable is s. So take it as s1 to s2. Left hand side, the variables are k. So k1 to k2, or you can take it as s in k initial to k final. So when you integrate dk with respect to when you integrate dk, you will get k from k1 to k2 is k2 minus k1 is equal to, what is the integral of ds from s1 to s2? This is the work done. This is work done by variable force. So work done will be equal to change in kinetic energy. So this is also called as work energy theorem. Okay, so write it down. So based on this, I'll give you a statement. First, make a note of it. So write down the statement. Sum of work done by all the external forces in the system is equal to the change in kinetic energy of the system. So this is the statement for work energy theorem. Done?
Yes, sir.
Okay. So this is one of the theorems in this chapter, that is work energy theorem. There is another important theorem that we are going to learn in this chapter that is called as energy conservation theorem. Okay. Before, I'll do one thing. Before I enter into the other theorem, energy conservation, what I will do is I'll explain you about two more concepts, which is called as conservative force and non-conservative force. Okay. So write it down. I'm going to explain about conservative force and non-conservative force. Have you heard these terms? Yes or no?
No, sir.
No, sir.
Sorry, I didn't get. Is it yes or no?
No,
No,
sir.
sir.
No. Okay. No problem. Listen. See, you know what is force, right? We already know what is force. Force is a push or pull, which is responsible for the motion of an object. So what do we mean by conservative is, when we say something is conserved, what do we mean by that?
We are saving it.
We are saving it in the sense we are not trying to change its value. That is the meaning, right? I'm talking in basic English. Conservative means the value of something is fixed, right? Here, by reading conservative force, you should not think that the force value is fixed. That is not the case. Because one thing you need to understand is conservative and conservation. Because I told you energy conservation theorem. Conservation means that particular parameter is conserved. Conservative means it is something else. Okay. When I explain it, you will understand. Listen to it carefully. We can say a particular force is conservative in nature. We can say a force is conservative in nature if the work done by the force is zero in round trip. Okay. So what I am trying to say here is there is a force that is existing, and we know that when you move when a force is applied and the object moves in the direction of application of force, work is said to be done by the force, right? So you're applying force on a particular object in a round trip. What do you mean by round trip? What do you mean by round trip? You're starting at a particular point, going to some other point, and then again coming back to the same point, right? So this is what is called as round trip. So what should a force which is conservative in nature should do? A force which is conservative in nature should do a zero work in the round trip. Okay. So let me explain what is the meaning of this. It is very, very easy. Concentrate. But see, this topic, this term is very, very important because you will see in many other branches of physics also. Now I'm taking an example. If there is an object of mass m that is projected upwards, let's say with velocity v, tell me what is the physics involved behind the motion of this object. The object goes to the top, its instantaneous velocity becomes 0. Let's say the object has traveled a distance of maximum height h. Let's say there is the initial point, there is the final point. Okay. So if I draw the free body diagram, then the only external force that is acting on the ball is mg. And the displacement of the object is in the upward direction. Now tell me, what is work done by mg from A to B?
Normal.
There is no normal at all. Work done, Geta, you're talking about force.
mg.
Again, you're talking about force. I'm asking what is the work done? 2 days we discussed about work done. Sorry?
mgh.
mgh.
It is mg. Force into displacement into cos 180.
Minus mgh.
Yes. Now, what is the work done by mg from B to A? That will be mg. So when the object is traveling from B to A, mg is acting in this direction, h is also in the downward direction, right? So mg into h into cos of how much value?
0.
0.
So it will be mgh2. So what is the work done by the force from A to A? That will be work done from A to B plus work done from B to A, accepted. So what is work done from A to B? Minus mgh. What is the work done from B to A? It is plus mgh. Answer will be 0. Now tell me which force is doing 0 work in the round trip?
B to A.
No, I'm asking which force. Try to understand the question. People are getting confused
Gravity.
between force and work done. Huh? I didn't get you. Which force did we take? What did I substitute in the place of force?
Gravitational force.
So that is what I was expecting, right? So from this we can say work done by gravitational force in a round trip is 0. Hence, what type of a force is it?
Conservative.
Conservative.
Okay, it is a conservative force. So please make a note of it. Write it down. I guess you people are not revising, right? Studying only in the last minute when I say there is a test. That's not going to help. I'm repeating it again. Mechanics, this particular branch of physics is one of the toughest. Unless you practice, I don't know what to do. It's not easy for me to teach. The people are getting confused between force and work done. What do I do? Tell me.
So on a conservative force, work done will be 0, sir.
Work done in what? What was the point I was stressing upon?
Gravitational force.
What is the point I stressed upon? Did I say always the work done is 0?
No, sir.
Then what is the keyword I told?
Total work.
Total work done in what?
Round.
That is the word you need to concentrate. Round trip. Means if you go from one place to another and then come back to the same place, that is called as round trip. If the work done in that round trip by any force is 0, then that force is what is called as conservative force. Okay. So write another important point about conservative force. Conservative force is path independent. Meaning of it is, work done by conservative force is path independent. Work done by conservative force is path independent. It depends only on initial and final position of the object. So what I'm trying to say is, let's say you want to move the object from A to B and you're applying a conservative force. Listen to it carefully. Your intention is to move the object from A to B and you're applying a conservative force. Whether you move the object from A to B in a straight line or whether you move the object from A to B along the second path or along the third path or anything of the sort, work done in all the scenarios will be the same, provided the forces
Constant.
conservative in nature. Provided the force is conservative in nature. So what I'm trying to say is, work done in 1 is equal to work done in 2 is equal to work done in 3 by okay.
Yes, sir.
Yes, sir.
Listen. Next is, then what will be a non-conservative force? work done by any force in a round trip is not equal to 0, force is said to be non-conservative. So what is the meaning here is, if I move the object from point A to point B, okay, if I move it from point A to point B of, let's say the object is of mass m, let us assume there is an external force F applied on the object, which is a constant force. Okay. If I say the surface is rough in nature, then what comes to your mind?
Friction.
Right. So when the object is moving from left to right, okay, when the object is moving from left to right, what is the direction of friction?
Right to left.
Right to left.
So I'm saying when the object is moving in this direction, it is in the direction right to left, means it is in the opposite direction of the external force F. So if I call it as Fk, let's say the distance between the points A and B is this. Okay. So you're going to point B. If the object has to move from point B to point A, you need to reverse the direction of your external force. Here you're going to apply the force in this direction. Then what will be the direction of friction in this case?
Left to right.
That is in the rightward direction. So this is going to be Fk, right? So I'm going to ask you the question as, work done by friction from A to B is what? What is the work done by friction from A to B? It is, see, work done means, I don't know why you people are thinking so much. Work done, there is only one formula, Fs cos theta. So what is the force I'm trying to talk about? I myself told friction. So write frictional force into what is the displacement of the object?
S.
S.
Yes, sir.
Cos of,
180.
that's right. So cos of 180 degrees. So that will be minus
Minus
Fk.
Fk.
That is equation number 1. Similarly, work done by friction from B to A is what?
Minus Fk.
So Fk into S into again cos 180 degrees. That will be minus Fk into S. That will be equation number. Right. Now tell me one thing. What is the total work done in round trip? Minus Fk into S plus minus Fk into S. Accepted? So this will be minus 2 times Fk into S. So which is a non-zero value. Are you guys able to understand this point? So here the work done by which force did we try to calculate?
Frictional force.
Yes. So since the work done by the frictional force in a round trip is not equal to 0, what is the conclusion?
The force is not conservative.
So frictional force is not conservative in nature. Okay. For that matter, any resistive force is not conservative in nature. The reason being, what is the reason? Because the work done by any resistive force in a round trip will not be equal to
Equal to
0.
0.
Okay, so what we are trying to say here is whenever you have a system and there is a non-conservative force acting in the system, there will always be loss of energy. So please make a note of it. Wherever non-conservative forces are present, the total energy of the system will not be conserved. Means there will be loss of energy in the form of heat, light, or sound. Okay.
1 minute.
Yeah. Okay. Now we'll go to the next one. So based on these factors, now we are going to define a theorem called as energy conservation theorem. So write down energy conservation theorem. See, there are differences, okay? You would have learned something called as energy conservation. You didn't learn theorem. So energy conservation states what? Energy can neither be created nor be destroyed, but it can be converted from one form to another. Right? Now, let's see what this energy conservation theorem actually speaks about. When a system is subjected to conservative forces, please underline this word. When a system is subjected to conservative forces, the total mechanical energy, that is in the bracket, I'm going to write it as kinetic energy plus potential energy, is always a constant. Okay. When a system is subjected to conservative forces, the total mechanical energy, that is the kinetic energy plus potential energy, is always a constant. I'll show you a simple proof. Okay. And let's understand what exactly do we mean by energy can be converted from one form to another. Now see, I'm taking a scenario where an object is moving under the influence of gravity. there is a block of mass in at point A. It is projected upwards. There is one instance where it is at point B. There is another instance where it is at point C. Right? I hope you guys are able to understand. So if I take the initial velocity as u. Now tell me one thing. When I draw a free body diagram of this block, after it leaves the contact with floor. So I've thrown the object up. So instantly what will happen? First thing is it will lose the contact with floor. As soon as it loses contact with floor, how many forces are acting on the system? It is only mg. So this is what is going to happen at point A. Am I right? So what is it telling? When there are conservative forces acting on the system, is weight a conservative force or a non-conservative force? Is gravitational force conservative or non-conservative?
Conservative.
It is conservative. So when it is subjected to conservative force, what is it we need to prove? The total mechanical energy means kinetic energy and potential energy is always a constant, means at every point it is the same value. So what is the total energy at point A? That is nothing but potential energy at point A plus kinetic energy at point A. I hope you're able to understand this, right? Now, what is the formula for potential energy?
mgh.
So potential energy is given as mgh, where h is the distance of the object from a line called as reference line. So what do you mean by reference line is, reference line is taken as the line with respect to which we are going to calculate the distance. So you can ask me, where do I choose the reference line? It is up to you. You choose anywhere you want, you will get the same answer. So here I am taking the bottommost line as the reference line. RL stands for reference line, right? Now tell me, with respect to the reference line at point A, how high the object is? Is it at any height which is a considerable value?
Okay.
So what will be the potential energy at point A? So what is the value of H at point A?
0.
With respect to reference line, it will be 0. Plus, what is the kinetic energy? It will be half mu square. Are you guys able to understand this? So what is the only energy the object possesses at point A? It is half mu square. So let me call this as equation number 1. Now let's talk about total energy at point C. Total energy at point C is potential energy at point C plus kinetic energy at point C. Correct? So what is the potential energy at point C? Let's say this is the maximum height. So what is the potential energy at point C? Let us say this height is h. Now tell me.
mgh, sir.
It is mgh. Okay. See, I will ask you 2 questions in this chapter. When I ask you work done, then you will take sign into consideration. Make a note of this. When I ask you a question about work done, you need to take a sign in consideration, because when the object has gone from A to C, mg is downwards, h is upwards. So it would have been minus mgh. But here I'm not writing minus mgh because I'm speaking about energy. So energy means sign is not considered. Okay, make a note of it. So you write the magnitude, that is more than sufficient. Plus, what is the kinetic energy at point C?
0.
Why?
It's at maximum height.
Yes, at the maximum height, it comes to instantaneous rest. So it is mgh equation number 2. Now I'm going to pass an important statement. Listen to me carefully. I'm saying total energy at point A is equal to total energy at point C. Because I'm going theoretically, okay? Because I am saying that the object is subjected to gravitational force, and gravitational force is conservative in nature, right? When it is conservative, the statement says total energy at point A is equal to total energy at point C. But mathematically, if you see, my equations are not supporting. It is half mu square. Here it is mgh. Are you guys able to understand what I'm trying to say? The statement of the theorem says that the total energy at A should be equal to total energy at C. But mathematics is saying that half mu square cannot be equal to mgh because they are different parameters. Except m, nothing is common in both. So what we will do is we will try to understand from the equations of motion. So v square minus u square is equal to 2as if I apply this along vertical direction. At the maximum height, velocity is 0 minus u square is equal to 2 into what is the acceleration of the object?
G.
It is minus g because it is in the downward direction. Displacement is h. So this and this will get cancelled. U square is equal to 2gh. Accepted? Right? I'm saying u square is equal to 2gh. If you use u square is equal to 2gh in first equation, what will you get? Half m into u square is 2gh. 2 and 2 will get cancelled. It will be mgh, which is nothing but
Potential energy.
the second equation. So what I'm trying to say here is half mu square and mgh mathematically, that is when you substitute all the values that are given to you, will generate same value. Means if this is coming out as 5 joule, this will also come out as 5 joule. That is the meaning of energy conservation theorem. It is not the mathematical expression. Are you able to understand this simple point? Yes or no?
So could you explain the last part again?
I'm saying if half mu square is going to generate a value of 5 joule, let's say I've given you mass of 1 kilogram, you have some value, such that when you substitute all those values, if it comes out as 5 joule, at which place? At point A. At point C, if you try to substitute all the values of m, g and h, this value will also come out as 5 joule. That is the meaning of energy conservation. Meaning, at every point in the motion of the object, the total energy will always be 5 joule. So, if suppose I take some other point D here, what will be the final total energy?
5 joules.
It will still be 5 joule. That is the meaning. Okay,
Understood.
that is the meaning of energy conservation. So, what I've done is I've taken two simple points. I'm going to take another point that is B. It is some intermediate point. So tell me what will be the total energy at point B? It will be potential energy at B plus kinetic energy at point B. Accepted? Now the point is, what is the potential energy at point B? See, this derivation is there in your textbook also. Okay. Listen. So what is the potential energy at point B? With respect to the reference, yes, that's right. With respect to the reference line, the object is at a height h dash plus what is the kinetic energy at point B? It will be half m into v square. Accepted? Yes or no? So mg h dash plus half m v square. So observe for journey.
Say you're not audible.
Yeah. Now is it better for journey A to B? Applying v square minus u square is equal to 2as. So what will I get? Velocity at b square minus u square is equal to 2 into what is the acceleration of the object?
Minus g.
Very good. height is? What is the height
H
that the
dash.
object is? Is it positive or negative?
Positive, sir.
Because it's in the upward direction, right? So I can say v square is equal to u square minus 2gh. So let me call this as equation number 3. Let me call this as equation number 4. So using 4 in 3, what do we get? mg into, I'm leaving h dash as it is, plus half m into, in the place of v square, can I substitute this? So when I expand it, what do I get? mg h dash minus, plus half mu square minus mg h dash. Did you understand what I did? I multiplied half m with both the terms. So what will get cancelled? mg h dash and mg h dash is common. So what is that you are getting? Half mu square. But what was half mu square? That was the initial energy the object possessed. So are you able to understand? You are able to visualize what is happening? The total energy at point A is mathematically the same as total energy at point C, is same as the total energy at point B. Okay. Is this clear? It is half mu square. So this is the meaning of energy conservation theorem. Okay. So listen to me very carefully. Next class, I'm going to do many derivations that are dependent on this. Unless you guys revise and come, I'm not going to proceed further. Okay, I'll ask individually. Secondly, people who are not speaking or you say you have mic issues, please get it resolved. I'm going to put a message in the group also. I want everybody to speak, or else I'll not know who is at which stand. Or what is your level, I cannot judge. So you guys revise and come. Next class, there will be individual questions that are being asked and you should be able to answer. And these are very, very important concepts, not only for your 11th standard, even for your 12th. The second chapter of your 12th is completely dependent on this chapter. If you don't understand this one, that is gone. So it's better you try to put in efforts. If you don't understand, I can help you. But if you don't speak, I can do nothing about it. At least respond for this. Am I clear with this?
Yes, sir.
Yes, sir.
Yes, sir.